What if we could solve problems in seconds that would otherwise take thousands of years? Welcome to the world of quantum computing, a realm where the conventional rules of computing are challenged and the boundaries of what we thought possible, extended. Imagine a supercomputer, its power dwarfed, its speed outmatched, by a machine no larger than your home computer. That's the promise of quantum computing. Using the principles of quantum mechanics, quantum computers can process information at an exponentially faster rate than their classical counterparts. This isn't just speculation. This is the future, unfolding right before our eyes. An era where complex problems that now stump our best supercomputers could be solved in mere moments. From drug discovery to climate modeling, the potential applications are staggering, but what does all this mean? How does it work, and why should we care? As we delve deeper, prepare for an exciting journey into the realm of quantum computing. To understand quantum computing, first we need to unravel the mysteries of the quantum world. Quantum mechanics, often considered the black sheep of physics, is a realm where particles can exist in multiple places at once, communicate instantaneously over vast distances, and even tunnel through impenetrable barriers. It's a world that defies our everyday logic and understanding, but it's precisely these bizarre properties that make quantum computing so revolutionary. Imagine a coin. In our everyday world, the coin can either be heads or tails. But in the quantum world, this coin can be both heads and tails at the same time. This is the principle of superposition. A quantum bit, or qubit, unlike a classical bit, isn't limited to being a 0 or 1. It can exist in a superposition of states, being both 0 and 1 at once. This allows a quantum computer to process a vast number of possibilities simultaneously. Now let's take two coins. In our world, flipping one coin doesn't affect the other. But in the quantum world, these coins can become entangled. Imagine that no matter where these coins are, flipping one instantly flips the other. This is the principle of entanglement. It allows qubits that are entangled to be linked together, such that the state of one qubit can instantly influence the state of another, regardless of the distance between them. These principles allow quantum computers to process information in ways that classical computers cannot. While a classical computer processes bits one at a time in a linear sequence, a quantum computer can process multiple inputs at once. This means quantum computers could solve complex problems like factoring large numbers or simulating complex molecular interactions much faster than their classical counterparts. Quantum mechanics, while complex, forms the backbone of quantum computing, enabling it to redefine the boundaries of computation. As we continue to unravel the mysteries of the quantum world, we edge closer to unlocking the full potential of quantum computing, a technology that promises to revolutionize our world. Now that we have a basic understanding of quantum mechanics, what exactly is a quantum computer? A quantum computer, unlike our traditional computers, operates on the principles of quantum mechanics. It's an entirely different beast, a radical departure from the computers we're used to. The heart of a quantum computer is its qubits, or quantum bits, which are the quantum analog to the binary bits of classical computers. In our everyday computers, bits are the smallest unit of data, existing as a 0 or a 1. However, qubits can exist in a state of 0, 1, or both at the same time, thanks to a quantum property known as superposition. This allows a quantum computer to process a vast number of possibilities simultaneously. But it doesn't stop there. Qubits can also be entangled, another quantum property, meaning the state of one qubit can be dependent on the state of another, no matter the distance between them. This interconnectedness provides a significant computational boost. Now let's talk about quantum gates. In classical computers, we have logic gates that perform operations on bits. In a similar vein, quantum computers have quantum gates. However, these quantum gates manipulate qubits in much more complex ways, allowing for a wide array of transformations. They can flip states, entangle qubits, and perform a slew of other operations, all in service of quantum algorithms. Quantum algorithms are the coded instructions that utilize the power of qubits and quantum gates. They're designed to solve complex problems in a fraction of the time it would take a classical computer. To put it simply, a quantum computer is a problem-solving powerhouse. But what does this all mean? In essence, the quantum computer, with its qubits, quantum gates, and quantum algorithms, represents a paradigm shift in computational power. It's like moving from the horse-drawn carriage to a rocket ship. Quantum computers, through their unique architecture and computational capabilities, promise to revolutionize the world of technology. Quantum computers aren't just theoretical constructs, they have practical applications that can change the world. Let's take a journey into the quantum realm, where these powerful machines hold the potential to revolutionize various fields. First up is drug discovery. The development of new medications often requires the simulation of molecular structures, a process that can take an immense amount of computational power and time. Quantum computers, with their ability to hold and process vast amounts of data simultaneously, could significantly speed up this process. This could potentially lead to faster development of life-saving treatments and medicines. Next, we have climate modeling. The complex nature of our planet's climate system often leaves even the most powerful classical computers struggling to keep up. Quantum computers, however, can simulate and analyze large, complex systems much more efficiently. This could give us a more accurate picture of our climate's future, and help us develop more effective strategies to combat climate change. But that's not all. Quantum computing also holds enormous potential in the field of cryptography. Today's encryption systems rely heavily on the difficulty of factoring large numbers, a task that's relatively easy for quantum computers. This could lead to the development of nearly unbreakable encryption methods, providing a new level of security in the digital world. But here's the really exciting part. These are just a few examples of how quantum computing can be applied. Its potential extends far beyond these fields, into areas we've yet to even imagine. With the ability to process information on a scale that's currently unfathomable, quantum computers could help us solve some of the greatest mysteries of our universe, and perhaps even uncover new ones. So, as we delve deeper into the quantum world, and as these powerful machines become more accessible, we can only begin to imagine the incredible possibilities they hold. These applications are just the tip of the iceberg when it comes to the potential of quantum computing. Despite its potential, the road to large-scale quantum computing isn't without challenges. At the heart of these challenges lie the qubits, the basic units of quantum information. Qubits are notoriously delicate. Their states can be easily disturbed or destroyed by their environment in a process known as decoherence. This makes maintaining qubit stability a significant hurdle in quantum computing. It's like trying to keep a spinning top from falling over, except imagine the top is a subatomic particle and the slightest breeze could knock it off balance. Another challenge is quantum error correction. Unlike classical bits, which are either 0 or 1, qubits can exist in multiple states simultaneously. This unique property allows quantum computers to process a vast amount of data at once, but it also makes them more prone to errors. These errors can occur as a result of factors like hardware imperfections or environmental disturbances, and they can significantly impact the results of quantum computations. And yet, despite these obstacles, the quantum computing field is not deterred. On the contrary, it's invigorated by the challenges. Researchers across the globe are steadily making progress in overcoming these hurdles. They are exploring innovative methods to protect qubits from decoherence, like using topological qubits, which are more resilient to environmental disturbances. They are also developing new quantum error correction techniques that can identify and fix errors during computation. However, it's not just about overcoming challenges, it's also about harnessing the full potential of quantum computing. Researchers are working on quantum algorithms, programming languages, and even quantum internet. They are pushing the boundaries of what's possible, paving the way for a future where quantum computers are as ubiquitous as smartphones are today. This is the exciting reality of quantum computing. It's a field filled with challenges, but it's also a field filled with possibility. It's a field that's pushing the boundaries of our understanding of the universe and our ability to manipulate it. Though challenges exist, the future of quantum computing shines bright, holding the promise of a technological revolution. So, are we on the brink of a quantum revolution? A question that has been hanging in the air as we've traversed the quantum world together. We've peeked into the future, unraveled the quantum world, and delved into the intricate machinery of quantum computers. We've looked at the potential applications from drug discovery to climate modeling, and discussed the challenges that lie ahead, from maintaining coherence to building reliable qubits. Quantum computing, despite its complexities, holds immense potential. It promises to solve problems that are currently beyond the reach of classical computers. It's a complex, fascinating, and occasionally bewildering field, but it's also an incredibly exciting one. The quantum revolution may be closer than we think, or it might still be a distant dream. Regardless, the journey towards it is filled with discovery and innovation. As we continue to decipher the mysteries of the quantum world, one thing is certain: quantum computing heralds a new era in technology. Stay tuned to witness this quantum leap into the future.